Hi, and welcome to episode 6 of Watch Me Code. So if last time we kind of were taking a diversion into how we manage the pipeline scripting, and this time we want to return now to actually dealing with the code. So I want to explain what the problem we're trying to solve is and kind of how we're going to get there. So we have something that's a minimal viable product in terms of what it actually does. If you remember, we have the ability for an organization folder and it will discover all the various different bits. But there is one important thing that's kind of an issue, and that is we have to do this git clone in order to discover what's in the repository. So once it's actually discovered the repository, that git clone, having it can be quite handy, but we're going to have to clone everything unless we ignore them. We're going to have to clone everything even if it's not going to be needed. And some of those repositories can be quite big and they end up taking up a lot of room on your master. Like if we go in here and cd work and cd caches, which is where they get hit, you'll see we've got a load of repository caches there. And we've only discovered 1, 2, 3 repositories. So we have 3 repositories discovered, but in order to do that, we had to clone 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 repositories. And du minus t star, oh no, it's minus s. Let's go minus, so no, minus m. Right, so in this case, it's not too bad, but you know, we've got one there that's 43 megabytes. If we went and we cloned even more stuff, we'd have even more repositories there. And the thing is, we shouldn't need to clone them in order to determine whether or not there is a branch that has a Jenkins file in it. I mean, if we go here and we look at this web page here for the web view, we can actually go and we can say, hey, you know what? Let's look at the tree for master. And oh, look, there's a Jenkins file. And so that's one level of issues that it'd be much nicer if we didn't even have to go and clone the repository just to check whether or not there's a Jenkins file. And then the other thing is when we actually get to a particular build, so I'm going to trigger a build. It's going to fail miserably, but that doesn't matter. What we'll find is it's got to fetch locally the repository again in order to get the Jenkins file. And so if we now go back here, and we cd cd jobs, cd maven. Oh. All right, cd jobs, cd, let's make this a bit wider. Maven, or it was test, isn't it? Yeah, test. Cd jobs, maven, and cd branches, cd master, and cd. So what we'll see is that we've got checkouts and various different things that are creeping in extra. Now, for this particular case, it's able to use the shared repository, but it's pulling a lot of stuff that we probably don't need. Wouldn't it be much nicer if we could just grab the contents of the Jenkins file directly? And so in order to save it, having to go and check out, and how this works is, when we check out, when we trigger a build on master, what's going to happen is we're going to end up checking out just to grab that one Jenkins file. Then we parse the Jenkins file, and then that's going to say, okay, go get a build agent that is running on Linux, and then do a checkout on the build agent, and then we then check out the repository on the build agent, and then we actually build on the build agent, and then we go and we get another build agent and we do another checkout on the other build agent. And we're going to end up checking out the repository 5 or 6 times, potentially. Now, okay, we need one for every build agent that we're building on, but this guy, just to get one file, is kind of a bit ridiculous. So what we want to do is we want to be able to grab that file directly using the URL. So we can see here that, you know, using the Git web interface, we can just ask for blob plain, there's a file, and there's a HB, right? What's HB? So we go digging. So if I go to the Git web conf, I did a little research beforehand, which is a little bit of a cheat, but it tells you H is the current hash and B the current hash base, which is the HB web parameter. So we know HB is the hash base. And if we look here, we'll see we've got H and we've got HB. So there's a bit of a puzzle as to when you have H and when you have HB and what's that about. Maybe we should try and dig into that. So git web source. And here's this guy. So if we look at HB, well, there's that help text again. Hash base. Let's look at hash base. So there's hash base. Let's see what we can find about hash base. Let's go to the top and start from the top. So hash base, list of actions that want hash base instead of hash, but can have no name parameter, tree and history. Interesting. And handcrafted links, hash base. We assume the hash parent base, hash base. Let's see what else we can find. So dispatch, if not defined action. That's so there's some ones where we don't care about the action. If we've got the hash, it'll kind of try and figure stuff out for you. So let's try this. If we just do that guy, that brings us to the commit. If we do this guy, no action, that gives us this page. So what's the difference with this one? So H gives us the commit, hash base doesn't, and defined file name. So here's, right. So if I go f equals Jenkinsfile, that brings us to the blob. So it seems to me that hash base is kind of used when you want to find out. So when you rename a file in Git, that file can move on. So if you're specifying hash base, what this seems, if I'm understanding correctly, is it's showing us the contents of this file, the Jenkins file, whatever its current name is, but in order to identify the file, we provide the hash base for that file. So we're going to have some fun constructing URLs, and then we've got some things that we want to do. So we want to be able to find out, if we go back here, or rather to this one, so we go to Maven again, and we look at what happens in the Multibranch Log. That's going to go and it's got to list all the branches. And again, this is using a checkout. So we want to avoid this checkout and list the branches, but you know, we've got this heads page, which tells us all the heads. And we've got this tags page that tells us all the tags, so we can get that information. And then we need to be able to look at the particular trees, so we can look at those trees, and we've got the raw information for that. And so how do we go about handling this? So in SCM API, there is this concept of a file system which allows you to peek inside of a repository. And there's a default implementation of it, which is the git SCM file system. And what that does is it uses this cache entry that we've seen and it clones it. So what we need to do is we need to provide an alternative implementation. Now, we can do that because if I wander down here, there should be, yes. So there is this extension mechanism, which is how we define it. So you define an extension and that defines it. But normally people do not specify an ordinal value. The ordinal defines the order in which the extensions get listed. And the first extension that claims it supports an SCM wins. So if you notice, the Git implementation uses an ordinal of -32768, which is different from the default ordinal of 0. So if we add an extension that matches the repositories on Apache and we don't specify the ordinal, that's going to by default come first, and so by default, without us having to do anything, it should match and win. So what we want to do is we want an SCM file system implementation that's going to win against the Git one for the Apache hosted repositories, and it's going to then go and dig in and do the appropriate manipulation. So we need to prepare for that, and the tasks we need to do are, well, we're going to have to scrape some HTML, and we know we're going to have all these URLs that have to be built. And one thing you start to realize once you've dealt with URLs that you're building is these URLs. So if we look, we've got this file thing here. Very often the file names can have URL unsafe fragments. So whatever we do about building this URL, we need to make sure that we use appropriate escaping. And the biggest bit about URL escaping that you need to keep in mind is there are different characters for different parts of the URL. So, I mean, this spec can drive you nuts. It's good to pay attention to it, but like you've got these percent encoding, reserved characters, and here's the unreserved characters, and when to encode, and various different bits. But like the key part is, you know, in different sections there are different encoding rules. So you need to know which section you're in order to know which encoding rule to apply. That's a lot of a pain to have to deal with. There is a lovely specification on how to define URI templates. And what URI templates use is there is actually a character that is not valid in URLs, and that is, well, it's actually two of them. It's open squiggly parenthesis and close squiggly parenthesis. And so by using the fact that those are not valid in URLs, you can actually define a template, and then we can use that template as a template expression. And so this RFC 6570 defines a specification for how to construct URL templates and allows you to just say, okay, for query bits here, and then a library that implements this has already figured out for each of the different components what are the correct expansion rules and escaping rules. And so if we just use a library that gives us URI templates, we can build all these URLs and not have to worry about the escaping rules. And it happens that there is a damn handy URI template library. So for Java. So we're going to build all the URLs using URI templates. So we're going to need this library. And we also want to scrape HTML. And there is, for Java, there is one and only one library that I recommend, which is Jsoup. It is usually the best for scraping and parsing HTML. And we're going to use that one. So we need to set up our class path and make sure everything's ready for those particular pieces. So this brings us to the next problem, which is we're now going to be adding dependencies in here. And in order to add dependencies, we need to be aware of how Jenkins bungs everything into a different class path. So in general, if there is a third-party library, so unzip myself target HPI. So in general, your plugin is going to have a webinf lib folder which contains any dependent libraries that are not plugins. What's going to happen in Jenkins in general is everything in your webinf lib folder is going to get munged into what's known as the Uber class loader. And all plugins will load classes from the Uber class loader. And so if I depend on a jar file and somebody else depends on the jar file, which version of the jar file wins is a matter of luck. Now, if the jar file I'm depending on is really good at keeping API binary compatibility, then there's no problem as long as the newest one wins. Or as long as the older one is compatible with what I need. But a lot of libraries are not like that. So, for example, one library that is particularly bad from the Jenkins plugin point of view at maintaining binary compatibility is Guava. Google's Guava has its own published policy on binary compatibility. That's really super, and bonus points for the Guava team for actually producing that binary compatibility contract and defining it and stating it up front. But that contract effectively means that unless you're at a very top layer in the application, you should not use Guava. And Jenkins plugins are not the top layer in the Jenkins application. Therefore, when you use Guava, you are stacking up a problem for things to go wrong. So that's one library we don't want to use. So if we want to make sure that there's only one version, there are two ways, or that we get the version we want. There's two ways we can handle it. I'm going to show both. So the first way is we can just depend on what's known as a wrapper plugin. So if you look here, we've got some wrapper plugins here already. We've got Jackson 2 API. Now, why is this called Jackson 2? Well, the reason is the Jackson library, when it went from version 1 to version 2, it did the correct thing and it changed its package names because it was breaking binary compatibility. That means you can have the Jackson 1 and Jackson 2 jar files on your class path at the same time and they will not conflict with each other. So, but what we do is in Jenkins, we create what's known as a plugin wrapper that just, its job is to give you the Jackson jar files. So it gives you the Jackson jar files with all the features of Jackson data bind. And so all you need to do is depend on that Jackson 2 API and it will then give you the Jackson 2 libraries. So that's the first way of doing things. So it happens that I've used Jsoup before. So if I go at, no, what's it called? Jsoup Jenkins we go, Jsoup Plugin. And this guy is Jsoup, and it's in org Jenkins CI. And we want tags 1.10.3. So that's the Jsoup plugin. There isn't one for Damhandy's templates. So in the case of Damhandy, we have two choices. We can go and create a wrapper plugin, or we can just say, you know what, let's add it in here. And you'll get to see what happens when we've added one. So if 7 Slapshot is the latest, then 6 is what they've got. Let's kill here, mvn clean package, skip tests. Now, Damhandy has, in the 2.0 series, tended to be very good at keeping the binary backward compatibility. So, you know, it would probably be a reasonable approach to take Damhandy and say, okay, let's just use that one and turn it into one of these plugins. We'd go and create a hosting request for that plugin against Jenkins, get that in, and then once that's in, then we could depend on that plugin and everything would be handy, pun intended. But if we look now, you'll see we've now got handy URI templates jar stuck in there in the web inf. And so now that jar file will be exposed to everybody. And if there's another version of the jar file, we don't know which version we're going to get. Now, that's exposing our code to a risk. I don't want to take that risk. So what I'm going to do is I'm going to say, you know what? All those classes there, don't find them outside of our plugin, because we're not going to show anybody else the URI template API. We just want to use it ourselves. So for that, we're going to need to add some configuration. Plugins, plugin, Maven, HPI, plugin. And we need a group ID, org. Tools? Yeah, there we go. And so we need to do configuration. And now we're going to go mask classes. Now, mask classes, separated list of package prefixes that your plugin doesn't want to see from core. And there's another one called global mask classes. Like the mask classes, but it applies at the boundary between core and all the plugins. Applies to the boundary between core and all the plugins. Not for us. So we just want mask classes. And I'm going to import changes. And com Damhandy comes up. So he's got com Damhandy URI template. Everything's in there. So let's go at com Damhandy URI template. So by doing that, we've said we don't care if somebody else has Damhandy URI templates. We want our one only. And so that should isolate us from that particular library being provided by anyone else with a different version. So that's the other approach. So the preferred approach in general is to use a plugin, but If the plugin changes binary compatibility, we need to start putting in numbers. So Jackson 1 to Jackson 2, that's why we added in this Jackson. So that, and similarly with async HTTP client, there's actually many binary breaking changes. So this is less good of a client. So you'll see there's async HTTP client, there's 1.7, there's 1.9, and various different things. And the binary compatibility is not maintained, even on minor updates, and that's really sad thing. And like they even changed packet, at least for the 2.0 change, they went and changed package namespace. But like what we really need to be doing is we need to be having, like, this should really have been async client 1.7. But anyway, so it can be tricky to decide at which point you want to make each appropriate jump. In this case, handy URI templates is one package namespace. It's easy to cut that out. And it's one artifact, and on top of that, the artifact is not very big. So it's an acceptable thing here. Whereas with Jsoup, it's got a very nice stable API, and there's already a plugin wrapper. It makes sense to use that. So if there's a plugin wrapper, use the plugin wrapper. If there isn't a plugin wrapper and you see multiple usages, then use then a plugin wrapper is the way to go. If there isn't a plugin wrapper and you're like one of the first people using it, then the mass classes approach works as well. So that's that. So now at this point, we need to get ourselves a class ASF get SCM file system. And we also are going to need a new Java class ASF get SCM file. So yeah. So this guy is going to extend SCM file. You'll see why in a second. And this guy now. Let me see, where are we? So GitHub, Git plugin. So what version are we on now? 3.6.4, okay. I want to update this to 3.6.4. And I'm going to be doing a lot of idiomatic code, so builds Apache org. I want to check something. Since we know this plugin is really only intended for builds Apache org, if it's on a sufficiently new version, we can probably start using the Java 8 APIs. So let's see what baseline version. So 2.7.3.1, right. So that says we should start using that as our base version. So 2.7.3.1, and we should go with Java. Now, what is it called? Java level. 8. I'm going to bung this up to 5. And let's get the plugin parent. Try 3.0. Is that the latest? MVN versions, update, parent, versions, commit. So 3 is the latest, so that's that. We're on the latest parent. We're on Java 8. Now, the latest parent, what does latest parent give us? By default, Java 8, that's great. And a reasonably new Jenkins one, but we can go one with the better one, so we don't actually need to specify Java 8 on this latest parent. There's that. So that should be all good. MVN clean verify. Now we've updated the Java parent. That's going to start adding in additional checks. So we may find that there's issues with our code. I think I'll wrap up in a second. Yes, here we go. So this is the latest parent. We're going to have to make sure everybody is playing with the correct dependencies. So I'll finish up once I've got this, and then we should be in a good place to start coding thereafter. So we've got a dependency on SCM API 223. We've got a dependency on Git 364, which uses structs 110. And Git client uses a different version of structs, and credentials uses a different version of structs. So the version of structs we end up with can be a bit tricky to determine, and so we want to make sure that all of them. Now, how does this get determined? So what you need to understand is that Maven starts with the highest order dependency works, and then it's the nearest in the tree. So if we look, we've got SCM API 223 depends on structs 19. That's the first dependency, and that's the nearest definition of structs. The next nearest is coming from Git, which is the second in order. So Git comes down here and it has structs 110, but that 110 is the same depth, so it's not going to take priority over this 19. The next one is further down. So Git itself has a transitive dependency on Git client, which depends on structs. So this guy is deeper, and so it's definitely ignored, as is this one. But this one is going to be the one that actually ends up getting picked. So what we need to do is either, well, we might as well update our SCM API. Anyway, so SCM API's latest version is 225. But we're probably going to have to put in a dependency on structs anyway. Structs 110. So that should get rid of the first pile of issues. And then the next set, we've got annotation indexer. Loads of different versions on that one. And we've JUnit. So annotation indexer 112. Now, annotation indexer is just a jar file. And I think we want this to be optional true, because I don't think it should be on our class path. Yes, it's coming from Jenkins core, so that should be excluded. Some of these, it's coming up as transitive under various different reasons. It's actually coming up, yes. So it's Git plugin depends on bridge minute annotation, which is exposing annotation indexer. But that's where that's coming from. And then the JUnit is coming from different ones. So let's go with that one. So because we're adding JUnit, uh, 1.3, I don't want that to actually come up as an actual dependency. So structs needs to be there, this guy. So let's clean verify again. So in general, you want to make sure that your plugins are using as new a parent as you can. And well, we're getting compiler errors because this guy doesn't have methods, so that's good. So let's implement methods. There we go. So let's import that guy. And let's see where we're at. Since nothing's referencing that class, it's fine that it's all just stub implementation. And ignore on push notifications is not to be used. So we've got some other binary changes that we need to pick up. Pub sub poll. So this guy is not to be used. Download sources. So we're not supposed to use that. We're supposed to check if it has the ignore. So if git traits contains SCM trait find. There we go. Right. So we get to the end of this. We should have ourselves now ready with the classes we need on the class path that we can start using Jsoup and damn handy URI templates. And the plugin should be building, and it should be designed to run against the version of Jenkins that the Apache Foundation is running with, and so therefore that's kind of a reason to go with. We could have gone with 260 as a nice one. We've got some find bugs warnings because that's been turned up and they're all on these things and stuff. So we can tidy up those find bugs issues at another point, but in general, we're now in a position where we can actually start coding. So next episode, we're going to try and start coding. We're probably not going to get very far in terms of getting it finished. We'll probably need another 2 to 3 episodes to get this file system working. So see you next time.